So the purpose of today's session is just to show you that there's another option to build your models to be used for energy modeling or even for just OTTV calculation. Because as you have seen last week, in IES, it can be hard to create models, especially when the building is big and there's a lot of rooms. It can really take time when you do it in IES. Whereas in Revit, at least if you're a bit used to the tools already, you can be able to build those models faster. So now I'm just gonna dive right into it. So the first thing you'll do is you'll create a new project. So here on the welcome screen, just click on new. And then you'll be prompted to choose a template. So this is the first thing. We always use our G-Energy analytical modeling template, the one I sent yesterday. So if you just go to where you have saved those files and choose this one. Okay, and just click open. And you're creating a new project, so just click OK. So it will upgrade the template to 2020 if you're using 2020. Just give it a little bit of time. Okay, so first screen, this is just like a welcome screen. Just type here the project name, sample project. And I'll just go ahead and double click first story here on the project browser. Okay. So let me just go through the interface quickly for those who haven't seen Revit before. So this main area here is our drawing area. This particular palette is called the properties palette. This is where you change the properties of the particular view, or if you're clicking on something, this will change. And this is going to show the properties of the particular object that you're selecting. This is the project browser. And this is where all the views are. For example, we have 4 stories in this project. So anytime you double click on a particular view, it's just gonna go ahead and open that view into a new tab. You can also open elevations from here. And if you're creating sheets, it's also here. So if anyone has used AutoCAD before, anything that's under the sheets tab or this sheets category is like the layout in AutoCAD. Whereas everything that's under the views category is like the model space. So if you double click on this, you'll open our drawing area. And this is the layout sheets. This is where you put your views eventually. But we're not gonna go to sheets today. We're just gonna build a model. So mostly we will be working on the views. So going back to first story. On top, you'll see the ribbon. So all the modeling tools that we need will be shown here. And mostly we're working with the architectural items. So if you know Revit, you can actually build structural elements, even the pipes and the ducts as well. It's all under systems. And then all these other tabs are in a way self-explanatory. If anything has to do with the view, you can likely find it here in this ribbon. All those general items that pertain to the whole project, it's probably going to be here in the Manage tab. And some of this are just add-ins, and this is a plugin. So again, when you select something, you'll see that the ribbon may change. This is called the contextual ribbon. So it will show you options that you can use particularly for the object that you're selecting. And then going back to architecture, this is where we'll work most of the time today. Okay, but for the first step, we're going to insert the AutoCAD plan that we received. So for that, we'll have to go to the Insert tab. And you have two options here. Either you link the CAD or you import the CAD. And the difference between these two is if you link the CAD, you can go ahead and change the CAD eventually, and you can reload those changes, and it will reflect here in Revit, sort of like an XREF in AutoCAD. Whereas if you import, it will become a static drawing, and any changes you make to the AutoCAD eventually will no longer apply here in Revit. So that's why ideally we always use link CAD. So go ahead and just click on link CAD. Then navigate to your training files again and click on this. If you're not seeing the drawing, it's probably because the file type is not set to DXF files. So if we have AutoCAD drawings, you can choose the WG files. Like for SMC4, I asked Uncle Jimmy to request for AutoCAD plans. So probably you'll be using DWG files for that. For today, we're using DXF. Click on the drawing and just have a look at the properties I have set here. First of all, I always choose this option, current view only. Let me just show you quickly what's the difference if we don't pick this one. And then I'll just link quickly. Yeah. So if I zoom all, you can zoom all by double clicking on the mouse wheel. And if I go to a 3D view, I can see it here on the floor plan now. But if I go to a 3D view, you can also see the CAD plan, which is not what we want. It can be very messy if you have, can you imagine if you have a high-rise tower and you have several plans linked in, you do not want to see all those AutoCAD plans in 3D view. So that's why we always, now going back, I'll just remove that CAD file again. And then I'll go back to link CAD. Click on this file. If I pick this one, you'll see later on that it cannot be seen on the 3D view. It's only visible on the current plan that I am in, which is first story. Okay, and then the settings for this, just choose preserve. It's just telling that I want to preserve the colors I see in AutoCAD. And if there are hidden layers in AutoCAD, I'll just want to see those that are shown. So I set it to visible. I know that the CAD plan is in millimeters, so I choose millimeters. And for the positioning, I'll choose origin to origin. So with this, I'll just click open. Again, I'll zoom all, double click the mouse wheel, and you should see the CAD plan somewhere around here relative to the origin point. And this origin point corresponds to the 0, 0 point in AutoCAD. So eventually, when you're linking CAD files for several floors, it's a good practice to be aware of the origin point of all those floor plans. Ideally, it should be in the same place for all the plans. For example, if you have grids, it's best, for example, to put that origin point in the intersection of grid A and grid 1 so that it's consistent across all the floors. So in that case, if it's not, for example, if it's all over the place, what we usually do is we just simply move the CAD file. For example, if this one doesn't have grids, right? So I can choose a point that's likely not going to change. For example, the lift core. If I know that it's consistent across all the floors, I just move this to 0, 0. And then I link it to our Revit file. So I do this for all the floors so that eventually when I link it in, I know they will stack up correctly for all the floors. But now we're not going to do that today. So we're just going to focus on this. And it's not so far away from our origin point, so it's okay. So the next step I always do once I link a CAD file is I just go ahead to visibility graphics. You can do that by pressing VV twice, or should be here under View, Visibility Graphics. It's either VV or VG. Okay, and then here you'll be able to adjust the presentation of all the elements in your model. For this particular case, I'm concerned with the CAD file that we linked in. It's a little too bright for me. I want it to be a bit half-toned. So I'll just pick half-tone for this particular file and I'll apply it. See how it became less brighter. Okay, so with this, we can start working. First thing is we're gonna create the exterior walls. So this one is very simple. We just go to architecture. We go to wall architectural. Okay, for the type of the wall, choose the exterior one. Oh, by the way, when we're building in Revit analytical models, we don't care so much about the thicknesses of the walls. As you can see, there's several thicknesses here. The lift core is bigger compared to the masonry walls, of course. But as you have seen in IES, everything becomes like a single plane or a face eventually. So we don't care so much about the thickness of the wall because we know eventually IES will only take the center line of that wall and convert it into a single face element. So that's why we only use one wall type for the exterior walls, 100 mm thick. And for the interior walls, we just try to differentiate it away from the exterior walls, but also it's only just 100 mm. Okay. So once you click on architectural wall, choose the wall type immediately, exterior, and just take a look at these properties that I have set. As much as possible, choose core face exterior for the location line so that you're aware which side is the exterior side. So when you're drawing left to right, the exterior side is the one on top, on the north side. So when you're drawing downwards, the exterior side is on the right side. When you're drawing right to left, exterior side is the south side. And when you're drawing upwards, exterior side is this side on the left. So if you click on a wall and it's in your choosing core face exterior location line, you'll see that the blue dots, that's where your location line is. And in this case, because it's exterior, you know this is the exterior side. So this can be important in some cases. So just, it's a good practice to be aware which side of your wall is the exterior side. So I'll just show you quickly. If I change this to wall center line, the blue line will be right on the middle. And if I choose core face interior, it's gonna go on to the right side. Okay, so for this case, just again, go to wall architecture, set all the properties correctly here. And then either you can choose the rectangle, but for this time, I'll just choose a line and I'll just quickly trace over this thing. Another thing that I prefer doing here in Revit is because I can snap more easily to the elements as compared to in IES. So I can find the intersection line of these two lines. If you're having trouble, you can even press SI, snap intersection, so that it doesn't snap to the endpoints. It's only gonna snap to the intersection lines. So SI is snap intersection. No need to press spacebar. You just, again, I'll just do it quickly. Wall, then SI. So it will look for intersection lines and then you can start drawing around. So this one, you just trace. Notice if I press shift, it will remain straight. Okay, so if I press shift and try to click on this line, I know I can be assured that it's straight. So same thing for here. I'll just keep on pressing shift. Okay, and then I'll just close it up here. Okay. So everything clear so far? I'm just gonna go ahead to 3D view to show what we have drawn. So it's a good practice also to check every once in a while what's being drawn in 3D so that you can be sure that it looks correct. Another thing that I forgot to stress is that we create walls always floor by floor. That means it's only one story high, from first story to second story, and no offsets. We try to avoid having walls that go from, for example, from first story to fourth story, although we know, for example, this particular wall is aligned all the way up. It's a good practice to split it up floor by floor. Anyway, we're gonna group this particular floor eventually, and we'll just copy that group, sort of a block in AutoCAD, so that once you edit one block, it will apply to all the floors. So we avoid having these types of walls that go from first story to fourth story. It makes it easier for IES to read the information this way. And it's also the practice in Singapore. When you're building models, they always tell you to do it this way. So we apply the same principles when we're doing our analytical models. Okay. So once we have the exterior walls, okay. Any questions? Oh, Wawa is here.
DJ, can you hear me?
Yes.
Okay, so now you just show us is the interior wall. So we are taking the interior wall with
Exterior.
100 mm.
Exterior wall. The exterior. Yeah.
Oh, exterior. Okay. Yeah. Okay, this is exterior inside there, and you take a one. The thickness is 100 mm as the exterior. Okay. Then the outer blue one. What is the outer blue one?
This one.
No, the outer blue one. Yes, this one. The right. Yeah.
The outer blue one is just the boundary of the CAD file.
Okay.
It's just
good.
imaginary.
Okay, good, thanks.
Yeah.
Okay, thanks.
Okay, yeah. And then the sunshades we'll draw later.
Okay.
These are just the sunshades. So once we have the exterior walls, the next step is I immediately draw the floor, because it's easy to select the exterior walls, isolate it, and then just create the floor according to the profile of the exterior walls. So I'll do that right now. If you hover over a wall and you press tab, it will select the chain of the walls. And if you click, you're basically selecting the whole chain already. As you can see, I have 4 walls selected. So go ahead and just do that. Hover over one wall, don't click yet, then press tab. And once you see the 4 walls highlighted, then you click on the left mouse button. Then you should have it selected. And then if I go here to this icon on the lower part of the drawing area, you'll see a temporary hide isolate icon. And I want to isolate this element. So I'll just click isolate element. This will hide everything else, making it easier for me to select objects without selecting those unwanted lines or points in the AutoCAD file. So I'll just go ahead and click floor, architectural. Then I have a couple of options here. I can just click on the rectangle tool since this is perfectly rectangular. And we try to click on the exterior side of the walls and then all the way to the other side here. Okay. So that's one option. Choose the rectangle tool, click from one corner to another. You can also click and manually trace over those walls again. Or another trick is you can again hover over one wall, find the center line of that wall, click tab, and it will select again those 4 walls, and then just click on the left mouse button. It will trace the outline of the wall. But right now, the main problem is it's in the center line of the wall. So that we can easily remedy by just clicking here on the modify tab. There's an offset tool here. Then I'll just specify an offset of 50 because I know that's half of 100. And I'll click this copy option so that again, I'll hover over one line, press tab, and then click. Then it can easily go out to the exterior of the wall. This is best when, for example, you have a crazy floor plan with a profile that goes all over the place. With that, you can just quickly press tab, and it will follow that outline, and then you can just offset it eventually. Okay, so it varies from case to case, whichever tool you use. Just make sure you're always up to the exterior side of the wall when you're creating floors. Okay, and then for the options, just make sure you're aligned to the story you are in for story, and there's no offset. So it should be perfectly aligned to the level of the floor plan. Okay, so once you have that floor, it may not be very visible here in plan, so you check on 3D. So
DJ, I have a question. Okay,
yep.
when you use a middle line indicator, and then when you use the 100 of serial,
the center line of the wall.
Yeah.
Okay.
When do you use the center line and when not to use it? You know, on what kind of situations?
For floors, we always go to the exterior side of the wall.
Yes.
We never stay on the. But if you're asking why I use this particular method,
yeah.
For example, if we have a floor plan that goes like this. For example, you have a floor plan that has this particular shape. So if I'm creating this floor, it can be difficult to, for example, you cannot use rectangle for sure because it's not going to follow that shape. You can manually trace over this wall, but again, it may take more time because you'll have to go here, go here, go here. So if you have a floor plan that's shaped like this, you can click on this pick lines tool instead. Hover over one wall and press tab. See, it follows the shape of the plan.
Okay, good, understand.
Okay, yeah. And then you offset it. Okay. Okay, so that's it for the walls. So after exterior walls, it's good practice to immediately draw the floors because you already have the outline of the building. So basically, the floor should follow the outline, the outermost part of facade of your building. Okay. So once we're here, you want to reveal the elements that we have hidden. Just go back to the spectacles icon, click on it, and then reset. Okay, so everything is back. Now you may see that the floor plan is not visible. That's because our view is currently in hidden line mode. Again, go to the bottom part here. This is the view control tab or bar. And then you just click on this and then turn to wireframe. Okay. And the shortcut for that is WF. You don't need to press space tab here in Revit. Unlike in AutoCAD, every time you have to do a command, you have to press enter or the space tab to activate the command. Here in Revit, once you have clicked the keys for the shortcut, example for hidden line mode, the shortcut is HL, it will activate right away. So right now I'll press WF, it goes to wireframe mode. Okay. So the next step after the floors, so everything's clear, no questions so far. Okay, so next step, we're gonna draw the interior walls. So same principle, just go to wall, architectural. Only difference is we're choosing interior walls for the wall type this time. But everything else is the same. We try to use core face exterior, first floor until second floor only. No bottom and top offset, so it's 0. Okay, and let's try to draw from here. Let's close this whole area up first. Again, you can try to click on the hold the shift button so that it's always straight. So okay, so in this case, if you saw, I tried to, because the wall is thicker on this compared to our wall type, but I'm trying to keep the area of the office more accurate. That's why I'm aligning to this side, similar to what Gene Harn taught us in IES. We try to maintain the area of the more important space. In this case, it's the office. So it's a case by case basis. You have to discern whether, for example, for lift between lift shafts and the lift lobby, which side am I going to align to? Maybe in this case, I want to align the wall to the exterior of the lift shaft in order to keep the area of the lift lobby more accurate, because I know it's going to be the one that's probably aircon space. And again, I'll just, oh, by the way, if you're clicking on a particular wall type, wall interior, you can right click and create similar, or the shortcut for that is CS, and it will copy all the properties of that particular element that you have clicked, and you can create new walls again. So I'm gonna follow the same profile that we did last time in IES. So just include everything here. No need to create this wall between the lift shaft and the LV bus duct. And then here, I'll just click on this. No, don't worry that you're not clicking on, you're not extending to the wall at this moment. I'll teach you how to extend walls eventually. And then just click and all the way to the exterior side. Okay, for this case, you have a couple of options. You can just drag it out, or there's a particular command here under modify. You can extend the walls. So you can click on this, click on the element that you want the wall to extend to, and click on the wall that you want to extend. Okay, so I have a shortcut for that, but I don't know if I don't think it's out of the box. So in Revit, you can choose to give your own keyboard shortcuts. Just go to File, Options, User Interface, Keyboard Shortcuts. And then look for the particular command that you want to add a shortcut for. For example, this time I want to extend. So here, as you can see, I have put in ED as my shortcut for that particular command, extend multiple elements. So you can just go ahead and add ED, then click on assign, then click OK, click OK. And now when you press ED, it will activate that command right away. Click on the face of the wall, then click on the wall that you want to extend. Okay. So this case, I can just draw this particular wall here. I'll just extend this one again, ED, extend. And this one, since we already have a wall here, I can just trim this. And the shortcut for that is TR, or you can click on this particular icon under the Modify tab, trim. And this works a lot like fillet in AutoCAD, fillet or fillet. So you just click on the two elements that you want to connect. Okay. So far we're almost done. We just need to add this additional walls here. Okay, and I'll create similar CS. Sorry, my mouse is malfunctioning. Okay. Oh, okay. So this case, I want to align to this wall, not that particular. Extend. And for the toilet, we just enclose them in one space again. Okay. So as far as the modeling of the interior walls, we're already done at this stage. So the next step, so far, no questions. Okay. So the next step we want to do is we want to add the windows. So for this case, we're just adding these windows here, 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 and up to here, up to this point. So for that, we go back again to architectural, window. As you can see, we only have one window type here. We are not, it doesn't even have the mullions or the frames, because as you have seen in IES, you can set the frames inside IES, or you cannot bother with it at all. It doesn't affect the energy model that much. So we're trying to simplify it as much as possible. So in this case, I just want to make sure the sill height is correct and the height. The width, you don't even have to bother so much about, because you can drag the extents eventually. So for this, the sill height, because I know, for example, this window is full height, I'll just set this to 0. And for the height, I'll set 3000. Okay. Then once you have those properties set, just click on the wall and it will put in the windows. Then you'll see you have this drag handles when you click on a window. Shucks. When you click on a window, you can see there's drag handles here. You can just drag it out. Or to be more accurate, you can use the Align tool under the Modify tab. Or you can press AL. It will activate this Align tool. So similar to Extend, you just click on the reference first. I want it to align to this line. And then you click on the side of the window that you want that element to align with. Okay. In this case, I want it to align to this one. Then I'll click on this side of the window. Now I'm gonna add here. First, let's check in 3D if it's correct. Okay, it looks good. So go back to your floor plan, activate the window command, WN is the shortcut. Make sure it's still correct. Cell height 0, height 3000, just click. In this case, if I want to align to the wall, as you can see, I cannot find the reference line anymore because I have set this window to go all the way to this edge. Two ways. You can just create a reference plane for reference purposes. Go to architecture, click on a reference plane, find that endpoint there, and draw horizontally. Then you can start to align. Or if you're lazy to draw that reference plane, you can just temporarily drag this out. Then just click that wall to align. And then this one, I can align here. Okay. So again, I'll check in 3D if it looks good. Okay. I'm just gonna continue to build these windows for all the sides. So in this case, I'll put the window here first. I'll click on align. Align this one first. Then I'll align this. Put this window here. Align here. Then I'll align this window. And finally, I'll just align to this wall. Now it's gonna prompt that you have conflicts here, because by right, you shouldn't have a wall or a window crossing this particular wall. But it's okay, we don't bother. IES will be able to solve this geometry when we import it, so it's okay. So if you look at it in 3D, it should look something like this. Go ahead and just save your file first. So I'll just save here. Choose only one. Okay, everything clear so far? No questions? Okay.
So your window here is throughout the whole or the wall, the same window. What happens if this one wall there are only five window opening, and the other on the length you get 8 window opening. So how do we do a duplicate? Suppose on your left and the right is only got 4 window. How you do a sampling on that?
Okay, if you have, for example, this floor plan doesn't show those divisioning, right? But for the sake of just answering your question, for example, if your floor plan shows the particular sides which are not window, or you have those solid walls, you can just simply drag your window again. You can just copy this over. So you can create whatever window configuration you have according to the floor plan. That's why it's important to have that AutoCAD plan from the architect so that you can trace exactly what you have shown there. And for this, you can individually change the heights. For example, for this particular window, it's 1000 mm from the ground, and it's 2000 mm high. So you can, once you have separate elements, you can set the properties differently for each of them. Okay, does that answer your question, Aljim?
Yes, that's right. Yes.
Okay.
Thanks. Yeah.
Okay, so I'll just go back. So if there's no other questions, as you can see, we're almost done here. We're just gonna add the sunshades now. So for that, if you see, we can actually build this sunshade as a floor. But when it goes to IES, since it's not covering a space or a room, it's not gonna translate into a local shade in IES, which is what we want. We want it to be that green colored surface when it comes to IES. That means it's a local shade. So for this, we're gonna use roof. we cannot use the floor element to represent the sunshade. So in order to do that, you go to architecture once again, roof by footprint. And then it's gonna ask you, since you're in the first story, it's just telling you that maybe you want to do this on the second story, but in this case, I'll just choose first story, and then I'll just specify an offset right away. And I want it to be on top of our window. Our window is 3000 mm high, so I'll just put 3000 mm for the base offset. Again, never mind the thickness, because it's only gonna take that bottom surface of the roof. I'll show you later. So just click on this particular roof type and start to draw. And for this, I want to snap to the endpoint. The shortcut for that is SE. Snap endpoint. Okay. Okay. Maybe first things first, I don't want this roof to have a slope. So I'll just untick this box because I want this to be flat. I'll show you later if you want to show the slope. For example, you have an inclined sunshade. You can also do it. You just have to specify the slope of the roof. But for now, let's just assume this is gonna be horizontal. So I'm just gonna click here, click here, click here, endpoint, endpoint. If you notice, you'll have those so many warnings. That's because the CAD file is not drawn properly. As you can see, if I'm drawing straight, it's not really aligned. So it's the problem of the CAD file. It's just alerting you that, hey, your lines are not perfectly horizontal or vertical. That's why Revit is showing us all these warnings. But I don't care. I just want to trace the outline of this particular sunshade as it was drawn. And I'll just close it up. Once you have an enclosed profile like this, you can finish. And then you can check in 3D what it looks like. And as you can see, what I was saying is that eventually in IES, only the surface will translate, this bottom one. So we don't care about the thickness of this thing because I know IES will eventually only take the surface. And you can see that later when I try to import into IES. But in this case, I want to show you something that we observe as a SOP when we were building this analytical models. We usually don't put a space between the sunshade and this particular facade because most likely it's gonna be connected unless they specifically told you that no, there's a space there. But most likely this one and the wall is there's always no gap. So in this case, I want the boundary of the sunshade to be aligned to the center line of the wall. So it's a different concept compared to when we're drawing floors. Remember, I ask you to align to the exterior of the walls. For roofs, we always align to the interior, to the center line of the wall. So in this case, again, I'm gonna click on the center line. This one is to the center line again. If you cannot find the center line, just, for example, in this case, you can just click on the exterior side, offset it by 50, then trim. Then I'll just trim this, unjoin, and I'll trim this too. Okay, so in this case, if I finish, it's slightly overlapping here, but it's perfectly okay. Because as I've said, IES will eventually turn this wall into a single face, and it will take the center line of that wall as the face. The roof should align to that center line so that in IIS it doesn't look like there's a space between the two elements. Okay. Okay. So this is done. We're done at this point. We just have to group this, and then we'll add the spaces eventually. So in order to group it, go to a 3D view. Again, the 3D view shortcut is here. Then select everything. And then go back to your floor plan while everything is still selected. It should highlight in blue if you have something selected. And this, just go here, create group, and then name it typical floor. So if I go back to our 3D view, you can see it's already a group. To edit it, you just have to edit the group, and then you're able to edit the elements inside. So from here, we just want to copy it to the other floors. But in this case, we want 5 floors. And as you can see, we only have 4 floors so far. So let's go to first story plan. And let's create a section here. And the shortcut for our section is, it should be here on your quick access here. There's a shortcut here, section, or you can go to your view tab and choose section. I think I have assigned SV as my shortcut, but I'm not sure if it's out of the box again. So just click on that icon there and then just draw from left to right. So you're able to see the extents of this section. As you can see, it's facing that way. So I can right click and go to view, or I can find the newly created section under sections here on the project browser. So you can double click on that. First things first, as you can see, I cannot see my levels. There's no indication that this is the first story. Where's my second story? I cannot see it. That's because the levels are somewhere around here only. So if I go to this elevation view, I'll try to click on this, right click, and go to elevation view. I want to see these elements there. So I'm not seeing it on that particular section. So all I have to do is I'll select all of these levels. I'll right click on it and I'll click on maximize 3D extents. It disappeared on this view because there's no 3D element here. There's nothing to show the extents for. So all the levels, if you can imagine, it's like a flat plane, and it's right now aligned to this 3D model. So if I go to this section view, here, the section should now appear. Okay. Everything clear so far? No questions? Okay. So in order to create that new level, 5th story, again, there's a couple of options. I can simply copy this. Shortcut is CO. Then I just choose a reference plane, a reference point, and then I click 4,000 mm high. Then I have my new level. But if you can see, there's a difference. This particular level is blue, while this is black. When it's black, that means there's no floor plan view for it yet. So you will have to go to view, create a plan view, floor plan, and it will show you that particular new level that you have created. So it's saying these are the views that don't have floor plans yet. And it's only showing this level because all the other levels already have floor plans assigned to them. And it's only showing this level because it's saying do not duplicate existing views, because there are views already assigned to the other levels. But if I unclick this, it's supposed to show me all the levels in the project. So that's one way, but I want Revit to automatically create the floor plan views for me. So that way I can choose architecture and the level command. Shortcut is LL. So I'll do that. I'll press LL. Click on the pick lines option. And I know my floor to floor height is 4,000. And then I'll just click on this. Notice how it automatically creates the floor plan views for me. Level 2, level 2. And I'll create one more for the roof level. Okay. Once you're done, press escape twice. And then you can go ahead and rename this particular level 5th story. When prompted to change, would you like to rename the corresponding views? Yes. So it changes here as well. And for the topmost, we'll just name it roof. Yes. Okay, as you can see, it even created the structural plans for me, but I don't need this, so I'll just delete them, highlight, and then delete. Okay. No questions. So I want to copy this particular group to all the other levels until the 5th story. Again, there's a few options. I can just simply copy from this elevation view, but this is a bit more prone to error. So that's why I don't like doing it this way. What I do is I click on this, just press Control C on your keyboard, Control C. Or you can even do it in floor plan view, Control C. Even in 3D view, Control C. Then under the Modify tab, there's this drop-down arrow for the paste command. And choose Align to selected levels. Then you can choose which levels you want to paste to. So I want 2nd to 5th. And then when I click OK, it will paste to all those levels. And I can be sure that it's perfectly aligned to my 1st story because I was not clicking manually. Okay. So again, if once you have, because this is a group, for example, if I delete this wall, it will apply to the other floors as well. So it makes it a bit easier to edit the models. For example, there are changes. Unlike in IES, as you have seen, Gene Harn had to delete his old groups first. He made the changes to the 1st story and then he copied it back to the other floors. So in this way, it's just a bit easier for us, especially during the early design stages. The design still keeps changing. So that's why we have to find a way to make it easier for us to do those changes without so much abortive work. So the only thing missing now from this model is the roof for the topmost floor. So we're just gonna go ahead and do that. We're gonna right click on the roof level. Oh, as you can see, it's not visible. That's because everything is only up to the it's best shown on section. So right now, we cannot see anything on the roof level because we're only seeing up to this point. So by right, it doesn't show those elements under this particular line, but there's ways to adjust that. So under the roof view, click on view range. It's somewhere around the bottom of the properties palette. Find this view range, edit, and this is just to explain. The view depth is this particular orange zone. So we can set a negative offset for this. even just a negative 500, for example, will show us what we need, because this negative 500 is already part of the fifth story. So if I click OK, then you will see the extents of the fifth story already. So for this is enough for me to be able to draw my roof. So I'll create roof by footprint again. So again, I don't have slopes because this is a flat roof. Then I'll just simply trace over. I'll use the rectangle tool this time. But again, since we're drawing roofs, we're aligning to the center line of the wall, not the exterior face of the wall. Center line of the wall, all the way to the other corner. This time, I want my offset to be negative 200. And I want, because I'm reflecting the thickness of this particular roof. So if I click OK, it should look like this. The top of the roof is perfectly aligned to the top of the wall. So anytime you have a roof deck, you specify an offset of negative 200 or whatever thickness your roof has, so that the top of the roof is aligned to the top of the wall. So it's a different case compared to the sunshades. Remember, in this case, we align the bottom of the sunshade to the top of the window. That's because this particular sunshade doesn't have a room or a space element underneath it. It's not enclosing anything. But in this case, this roof will be enclosing the spaces inside the fifth story. That's why we do it this way. Okay? Okay, no questions so far. So again, go ahead and just save it first. Now, this is almost the last step. We're just gonna add the spaces inside this thing. Because right now, this is like an empty shell only. We have the boundaries of the rooms, but the actual rooms, we don't have it yet. So for this, we go to Analyze. We're using space elements in this case. So we click on space. First things first, always set the properties correctly before you click on anything. You can click on this manually, but there's an easier way. So we just have to set the properties correctly first. So second story, and I want the limit. The limit here pertains to the upper limit, which is the top of the room. I don't want it to have an offset. I just want it from first story to second story. And for the room tag, I just want space tag only. I don't want to see the area. I don't even need to see the space number. I just want you to show me the room name. So, okay. Once the properties are all correct, you can click on this icon here, place spaces automatically. So it will tell you that it has placed 8 spaces on your particular floor plan. It may not be very visible right now, but it's there, because when you try to hover, you'll see that X line and you have this space tags. There's actually 2 elements here. If you try to window select like this from right to left, you're actually selecting, it's saying 3 elements. So you can check which are those elements. It's saying that I actually selected the AutoCAD file, and I have the space tag and the space element. So the space tag, you can delete this without affecting the space. It's just that there's no tag, and you can easily re-tag this thing as long as the space is still there. And to make it easier to see the spaces, we're going back to VV, or the visibility graphics, VG. And let's look for the space elements here. Under the model categories, since it's a 3D element, it's under model categories. And then spaces, just click on this interior category here. And then you should be able to see it in green. Now we're seeing that this spaces in green have the space element assigned to it. Okay. And then from here, you just rename it. Click on the space tag, lift lobby. Go ahead and just do this step as well. Just name them accordingly. Lift shaft, toilets, stairs, service corridor, risers, HU room, and office. And then I'll just go back to hidden line view so that it's a bit more clear. You can drag these things down if it's overlapping with other elements. So no questions so far? Everything is clear? Hafizel just joined, is it? Okay. So just before we copy this space, again, we can just copy the space elements up to the other floors. But just before we do that, there's one more step that we have to do. Just click on this space, one of the space elements, try to hover over one room, try to click on this X line, not the space tag, okay? The actual space element. And there's a couple of things that we want to set under its properties. So these are toilets. So the conditioning type should be vented. Or if it's an aircon space, then we just put cooled. But since this is, let's assume this is mechanically ventilated. So we'll just put on vented. Lift shaft is unconditioned. The lift lobby is aircon, so it's cooled. Stairs is again vented. So as the HU room, get vented. Risers. If you're having trouble clicking on the actual space element, for example, like in this case, I cannot find that X thing. You can hover over this space tag and press tab. And it will cycle through all the elements that are overlapping. So this applies to other things as well. For example, you have a floor and a wall overlapping at this edge, right? You can press on tab until you find that particular element that you want to select. Okay. So in this case, I want to be able to select the space element. So I'll just hover over the space tag, press on tab, and I can see it's highlighting the space element already. I can click. And then I can change the conditioning type to unconditioned. And finally, for the office, I want it to be cooled. So this is what Gene Harn mentioned. You can actually assign the people load, electrical load to all the spaces already here in Revit. And by right, he said it will translate to IES. Back when we started doing this particular functionality wasn't there yet. So we never do this step before. But I will be looking into it. If it really translates properly into IES, maybe we can start inputting those particular information that we already know here in Revit before we even import it into IES. But for now, we're not gonna bother about it. We just want this conditioning type to be there. Cool. So once you have set the conditioning type for everything, again, just one more step, just click on one of the spaces. Let's isolate the category. To do that, we're going to the spectacles icon again. And instead of isolate element, or choosing isolate category so that it isolates all the space elements in the view. This way I can select easily. And since we're in the first story, I want you to add this particular space level. Look for this particular parameter, space level. Just type L1. Okay, and then press apply or just click on the drawing area. So by right, when you reset, this is the reset to reveal all the hidden elements. So when I click on any of the spaces by right, it should show L1 under the space level. Okay. Now this time we can actually still select this way as well. Select everything, go to filter, and I only want to select the space elements and the space tags. So I have these 2 elements selected. There should be 8 for each, and then just press OK. So it's selecting only those elements. Then Control C to copy. Okay, Control C, copy to clipboard. And again, I'm gonna paste, but this time I'm gonna paste, I don't think the paste aligned to selected levels is available for this case. So in this case, you have to go to the second floor plan, go to the modify tab, paste aligned to current view. Okay, it will put it there. And before you click anything else, I want you to deselect the space tags and then press OK. Then immediately put in L2 for the space level. Okay, and then enter. Okay, so when I click on this space, it should be L2. And just do that for the other floors as well. Control Shift V is my shortcut for paste aligned to current view. Then again, deselect the space tags. Add in L3 for the space level. Press enter. Fourth story, Control Shift V. Filter, deselect the space tags, and put in L4. Enter. And then fifth story, Control Shift V. Filter, space tags, and put in L5. Okay. So everyone able to follow that step? Okay, no questions, huh? So by right, we have put the spaces on all the levels already. Just to double check, you can check under here, schedules. We already have some pre-made space schedules here. So you should see all your levels listed down here. So you should see also the conditioning type here. So I can see that it looks correct. I have 5 floors and all the levels are there. So one last step, if you remember, Gene Harn put L1 before our space names, right? L1 lift shaft, L1 lift lobby, just to make it easier once you're in IES to see which spaces are in which particular level. So in order to do that fast here in Revit, I mean, we can have done it by typing manually L1 office. And then once you go to the second floor, you edit the name to have L2. But again, once you have a very big floor plan, that can be very tedious. So that's why we have put in that particular parameter here, space level, because this way we can just run a script that puts in this particular prefix to all the spaces on the first floor. So we'll do that now. I'll just save first. And then I'll go to manage and open Dynamo. So this is the scripting plugin inside Revit. So this can automate those tedious tasks so that you don't have to do it manually. Does everyone have Dynamo? I suppose if you're using 2020, it should be pre-installed already once you install Revit. So once it opens up, can you see my Dynamo screen or not? Everyone, can you see my Dynamo screen?
Yeah, you can see a Dynamo screen, yes.
Okay, yeah, good. So you go ahead and open. And then I have sent you that particular Dynamo script along with the training files. So just navigate to that folder where you have saved it. It's called this one, Zeb Add Space Level. Just click open. Okay, once you have this open, all you have to do is click on run. And it should just take very fast. Then all your spaces should have that L1 prefix already. L3 should have L3. L5, L5, okay. So it looks correct. So this one, once you have done that step, we're ready to export our model to gbxml. So this one, just go to a 3D view first. So everyone, okay, that step is already done. Okay, no questions. Okay, so go to the 3D view, go to File, Export, then gbxml. For this, we choose space volumes. Okay, export gbxml, use space volumes. Once you're prompted this, you just say yes. Yes, I want areas and volume settings instead. Yes. So first things first, let's set the location to Singapore or Malaysia. So in order to do that, yes. Any questions?
Your Dynamo window is covering your Revit.
Oh, okay. I'll just close this. Okay, so I'll start that again. Go to File, Export, gbxml. Use space volumes. Yes. And first thing we need to do is we need to change the location to whatever you want. So in this case, I want Singapore. I'll just search for it. Then I'll just click. I'll search, and then I'll click on this, so that will set it to Singapore. And then I'll click OK. The ground plane should be the first story. And in this case, we use spaces instead of rooms. So we're going to choose spaces. And by right, you should see that it will turn green here. For this, all these other options, you just choose the default. Basically, we only want, as much as possible, we only use this option, simple. And we want those shading surfaces to translate. All the sunshades that we have created outside the building, we want it to translate into IES. So we're choosing this one, simple with shading surfaces. Okay, and then we go to next. Then we just save the file. In this case, I'll just save it here. Now I'll jump right into IES. I think I need to share my IES screen. Are you able to see my IES screen? Okay. Then from here, I'll just create a new project. Click create. And I'll go to import file, import gbxml. Then I'll click on this button to locate my gbxml file. Should be this one. Okay. Okay, let it just run. You can preview it here, and then you can click on OK. Okay, once you're here, if you're not seeing any diagonal lines or if it looks clean, basically, then it has made the import successfully. Or basically, we want something that looks like this. We don't want any unwanted lines or unnecessary lines crossing from one point to another. So this is good enough to start your energy modeling or your OTTV calculations. This is what I'm talking about when we trace the outline of our roof for the sunshades. We aligned it to the center line of the walls. So as you can see, it's perfectly aligned to the boundary of the room element. Because if you have only traced until the exterior face of the wall, you might see a gap between these two. And for this top one, if we have traced the outer face of the wall, you might see something protruding out of this particular profile, like it's cantilevered a little bit. To be particular, it's 50 mm cantilevered because that's how much the outer face is away from the center line of the wall. So you'll have that unnecessary green protrusion on the profile of the roof. So that's not what we want. So we want something that looks like this. Okay. So if everything is clear, I just want to go through a few more things, something more particular. For example, when you're doing daylight modeling, I'll try to open. Yes.
Sorry to interrupt.
Yeah.
My screen, I only can see importing space 92%, and then the import check is only half true. I don't know. It's hang or what?
It's maybe your
screen.
PC is taking longer to. My screen, is it?
Yeah, I see your screen. Nothing.
Oh, okay. Maybe it hang a little because
I don't see anything there. Anybody see anything? Any images? I don't see anything.
Are you seeing the plan now?
No, nothing. Strange.
I'm asking the others. What are you guys seeing? Thomas, are you seeing my floor plan?
See here, so nothing. See anything.
Okay. Let me redo my share. Okay, I'll share again. Can you see it now?
Yep, I can see the plan.
Okay, so let me just go back to what I was talking about regarding the roofs. Are you seeing the 3D view now?
Yes. Yeah.
Okay, yeah. So again, because this sunshades we align to the center line of the walls, as you can see, it's perfectly aligned to the outer limits of the room, the space. So in that case, we have done it correctly. This is what we want. We don't want a gap between these two elements. Because if we have drawn it to the outer face of the wall, you will have that gap, and that's unwanted. Again, for the roof, we align to the center line of the wall. See how it's also just perfectly closing it up. Unlike if we align to the exterior side of the wall, you will see that there's something cantilevering out on all the sides, because it's considering anything outside of the wall center line to be a sunshade. So that's not what we want. We want something like this. It looks clean and no unnecessary local shades or anything. Okay. So now I'll just go back to Revit. Let me just go back to Revit. Sure. I'll open up one of the files. So this is just the first story file. If you notice what we did, we ignored the interior columns earlier. We didn't do them at all. But in case you're doing, let's do it here. I'll just delete the other floors. I'll transfer this to the first, second story. If you're doing daylight modeling or daylight and glare simulation, you have to have these columns inside because it's not going to be accurate without them. So if you're doing energy modeling, it's totally okay to ignore it, as Gene Harn told us. But if you're doing daylight, you have to have these columns because if you're having a view here, by right, you should be able to see something blocking the sunlight coming in. So in this case, we actually have a column command here in Revit, but it doesn't translate to IES correctly. So in this case, we still have to create walls. So again, we're using interior walls here. Same principle, we're just gonna try to enclose this space, like so. And then I'm just gonna copy this over to the other columns. As you can see, the column, I don't know if the architect intended it to be this way, but it's not straight. So always be wary of those cases. So this one, I want to copy again. And if you're trying to copy multiple items, just make sure you have this stick so that it doesn't stop after you copy one. So if you have multiple check, if I copy here, it allows me to continue to copy to the other areas as well. Okay, so once we have that, if I go to hidden line view, you see that I have the spaces inside the columns that are not green in color. That means there's no space element inside of them. And that could be a problem when it comes to IES because they might consider this as an exterior wall. Because anything that doesn't have a space adjacent to it, IES may think it's an exterior space. So when you go to IES, he might consider this an exterior space. So that's not what we want. So we'll just have to put spaces in these areas as well. So again, to do that, we just go to analyze space, first story to second story, no offsets, and this just place spaces automatically again. It will add those spaces in. I'm not even gonna rename it. I'll just keep it a space so that I know these are the columns inside the project, or you can just put in columns. But just to show you that this step is not yet finished, even though it looks correct already. I'm just gonna quickly export the gbxml file from this. And I'll just stop my sharing. I'll switch to IES quickly. Can you see my IES now?
Yes,
Anyone?
I can see it. Yes, I can see it.
Okay, yeah. So I'll create a new project again. Quick create project. Then I'm gonna try to import that new model that we have just exported. gbxml file, import sample project 2. Okay, so just press OK. Are you seeing my floor plan now? Yes.
Yes.
Okay. So this is an example of a messy model. This is not what we want. As you can see, there are diagonal lines running all over the place, and this may give you problems eventually. Although you may still be able to run your OTPV, but when it comes to energy modeling, it might present some errors, or it might take longer to create those simulations. So that's why we try to avoid this. And this happened because the main reason is IES doesn't like this type of space where it's like a donut. It's a space within a space. So this is explicitly laid out in their guidelines that we avoid this kind of situation wherein we have a space within a space. So to remedy this, it's simple. We just create a space separator. We create a line from here to here, and we just continue to separate this this main space from this outer space. So we'll just continue to create that line here. Once it's properly enclosed, you will see that the office will turn green again because it's properly enclosed now. But we have to add this particular space again. So I'll just press space is correct automatically. And then I'll just copy and paste this one here. Okay. Once we have this, I'll just quickly export to a gbxml file again. Close this, create the new project. And I'll import the new file. Okay, so right from the get-go, you'll see that it looks much cleaner this time. What happened? Did I not import it correctly? Sorry. Okay, so when you check in 3D, now it looks much cleaner. So again, this is better. So all we had to do was just add those lines in. Anyway, in IES, you can eventually merge those spaces as Gene Harn showed us that time. So you can just click on this to merge. I forgot where it is, but I think you can merge through this. So this one, yeah. Anyway, you can do the merging. I'm not very familiar with it, but you can combine these two spaces eventually, or you can just keep them separated. Anyway, you can just run your OTTV with them being separate spaces. Okay, so that's basically it. So just be aware of those donut spaces. Another error that may may present problems like that is, for example, if the AutoCAD file, for example, if you have a situation that looks something like this is not, for example, if the CAD file shows that there really is a kink here, that's the design of the architect. But in our case, since it's such a small kink, like this outer face and the inner face of this wall is almost the same or exactly the same, we try to avoid this situation because it's going to present problems for us when we do the energy modeling. So there's no harm trying to align this wall, even though in the CAD plan, architect's intent is to have that kink. In our case, it's not going to affect our energy model that much. So it's okay to totally go or to deviate away from the architectural drawing in that regard. It's just a small kink. We can just assume it's aligned. So same thing applies, for example, if we have this wall thicknesses that varies from one space to another, like this case and this case, we try to keep a straight line as much as possible. We don't create this kink just for the sake of trying to stay true to the architectural intent. We have to balance it with the functionality of our software. And there's limits to IES. It cannot follow two complex shapes. So and if it's circular, for example, if we have plans that are round, that has a round profile, what we do is we try to facet it. I mean, create several straight lines. Try to stay as close as possible to the arc of the circle, but without actually being an actual circle. Because again, IES is going to translate it anyway to straight lines. So when we have those circular plans, we try to divide the entire circle into 8 segments or 12 segments if you want, so that it's not curved. It looks curved when you look at it from afar, but it's not perfectly curved when you look at the model. So those are the basic principles that we try to apply when we create these models. And once you start doing it, you'll get the hang of it. It becomes like a game that you're able to create something that looks clean when once it's in IES. And you may have to go back and forth from Revit to IES, export gbxml, check whether it's correct in IES. And ideally, what we should have done, is once we have finished the first story, we should have put in the spaces immediately, just enclosed that particular floor with a roof, exported the gbxml, and just checked in IES whether it's already looking correct. That way, for each floor that we create, we know that we're doing it correctly, so that it doesn't have the final checking doesn't have to happen only at the end of the modeling process. You can check intermittently between those floors. Example, if you're creating a high-rise tower, after you create the first floor lobby floor, export a gbxml right away, check in IES if it's correct. And then once it's correct, you start to draw the other floors. And anytime you have a new typical floor, for example, at the middle of the tower, you have a sky garden. So once you create that particular level, again, try to export a gbxml file before continuing to model the other floors. That way you can manage the errors easier, because surely there's going to be errors, especially when you try to do this SMC4. I'm sure you're going to experience a few hiccups along the way. And when you do try to build this model, you can still ask me, you can message me in WhatsApp or email me if you have questions, and I'll try to answer them as quickly as possible. Okay. So, Jimmy, I think that's pretty much it. What I'm gonna try to do is I'm gonna send you a cheat sheet so that let me just finish this. It's like a document that allows you to go through the steps easier, so you know which properties you should check before you start drawing the elements. Okay, I'll finish this today hopefully, and then I'll send it over to by email. Okay.
A few questions here.
Sure.
Now, with this model here, right now, we can do the energy modeling. Now, at the same time, it also can do for calculation of OTTV.
Yeah. Same model you can use for any of the modules inside IES.
So in a module of IES, the OTTV, when you import the same whole this model that you have, or you have to split it up or thing like that.
No need to even import. Just once you import it, it's done. You can run any of these modules here. This is for energy modeling. So you just have to click on the appropriate module. Once the model is inside, all these modules you can run already.
Okay, said Apache or whatever, it will tell you to run itself.
Yeah.
Okay, just for kind of same, if the same models like these models here, and if you will do the OTTV and then energy modeling, first thing, the donut spaces, it doesn't affect the OTTV calculation, neither they affect the energy modeling. So in the first place, if you don't draw this donut spacing, does it affect it?
If you know that you're not gonna do daylight, you can avoid doing these columns totally, because this only matters when you're doing daylight and glare simulation, because you want to be accurate when you're doing that, so you need to have this obstruction. But since you know that you're only doing OTTV and energy modeling, you can totally ignore this interior columns.
Okay.
So you don't even have to draw them at all in Revit.
Okay. Another question is, suppose right now this model is only all vertical shading. Now, what happen if I have vertical shadings? One side of the wall is vertical shading, and the other side of the wall, the windows are not all full of ceiling or floor to ceiling, but partitions kind of window. So, of course, how does it go now?
Okay, yeah. For vertical shading, all you have to do is create walls outside. Again, you just choose maybe exterior wall, or you can even create a new wall type. It's just
okay. Maybe say second floor and fourth floor we have a vertical shading, and then first and third floor we have a separated window on one side. Example.
Okay. Yeah. For this case, I just created this new wall type, sunshades, and maybe I'll just put here. This is just for the sake of demonstration. I'll just quickly copy this. How about I have this 3 only, yeah? And I'll just try to export right away. So anything outside of if it's not enclosing a space, it's gonna translate as a sunshade in IES. So,
yes.
So I'll just choose sunshade sample project 4. So I'll try to import the new file. Okay, as you can see, it's gonna translate as vertical sunshade, and again, it's only taking the center line of that wall. So it becomes again a singular plane once it's in IES. So it doesn't matter how thick you make the wall in Revit. Okay, I don't know why it's a bit. It looks like it's overlapping, but by right, this is good enough. This is what we have always done for our previous projects since we applied this workflow. Okay, so that's for the vertical sunshades. And again, for the windows, you can just adjust the height and create separate windows for those for those different dimensions. Okay. Anything else, Uncle Jim?
For myself, okay. How about the rest? Any question that you want to clarify or make your understanding better for this modeling? Please feel free to ask now.
Yeah.
Serge?
Yeah.
Just a quick one. For those buildings with like mezzanine spaces, where one space encompasses 2 levels,
Oh, yeah.
do we still assign the space floor by floor or?
Yes. In that case, it's more ideal again to do it floor by floor. So, for example, you have a lobby that's double height, right?
Yeah.
You still split the first floor lobby, and then you'll have another lobby space for the mezzanine level. So it's still called lobby, but it's on the mezzanine level until level 2. And then your lobby space for level 1 is until the mezzanine space only.
Okay.
And then eventually in IS, as Gene Horn has shown us again, you can change the
Just merge.
material of the spaces, like the floor of that particular lobby space. You can turn it into a transparent opening eventually in IES, because it's gonna present problems again when you try to do those spaces that encompasses 2 levels. It's gonna present more challenges for you, so you can just easily do it in IES. So
okay, go ahead.
that's it.
So for the mezzanine level, we still have to make a floor, even though
Yes.
it's a void. Okay.
Yes. Oh, that's the thing. If you notice in here, even though this is a lift shaft, by right it should be a void, we still created that floor. Even these risers, we have a floor underneath it. By right, it doesn't have, right? But for analytical modeling purposes, we always try to enclose the spaces from the top, from the bottom, from the sides. So that's why we always create those room bounding elements to enclose. And then if needed, you can just change the materials in IES. But in this case, I don't think it doesn't apply too much. So you can just leave it as is. So just create those floors, even though there's a hole. And then if it's a special case like a double height lobby, then that's the time you have to change the material in IES.
Okay. Thank you.
Yeah.
DJ, okay. Just having built this model, and then when we import or export into the IES program to run the OTTV or energy modeling, how long it takes to generate, churn out the result? Example for OTTV.
The OTTV, Uncle Jimmy, I've only seen it the first time when we did the training, and
Okay, you talk to share.
it's a relatively small model, so took quite
So I
fast.
take how long? Half a day? 1-2 hours to the result out, or take a couple of days?
Maybe give it a few hours. I don't think it's gonna last like a half a day, but it should in an hour or
okay.
less than an
And
hour.
how about for energy modeling? Usually, in your experience, how fast will the result come out from the energy modeling after the model has been put in?
Energy modeling, since there's still a few steps that you have to go through after you have imported, you still have to put those inputs though. So those can take time. So we usually allot at least a week from the date that you
I mean,
that you
a
import
week.
the model. Yeah.
I mean, after importing, you take a week for result to come out, or you preparation for this
No,
simplified model take a week.
the entire thing usually takes a week to 2 weeks. That includes the inputting of the necessary info and running the actual simulation itself. I don't do the energy modeling myself. Samantha used to do it for us, and that's basically the timeline that we have always in mind. Once we have given her the model, it usually takes her about a week to 2 weeks, depending on the size of the project and the complexity of the ACMD system. So that should be that should give you some idea that at least you have this 1 to 2 weeks if you're doing energy modeling. But OTTV should be a lot simpler than that. You just need to assign the constructions. So maybe a week or less if it's the model is not that complicated.
Okay, maybe the rest of our team, do you want to share some question? Because in our team, we do a lot of OTTV calculations and ETTV, manually we calculated. And of course, energy modeling, we use E20 to do the energy modeling. So that's why I want to see feedback from our side and from your what you have learned. I mean, what you have see, how can we incorporate this thing? I just want to see which one is more productive. Using IES, or we still go back to our E20 and our manual calculation of OTTV. That's why I want to see which one could raise our productivity, save our time, and things like that. Maybe the input from the rest of people. You've gone through, what do you feel? How is the feeling like? The rest got no input? Yeah, you're okay for this one? Okay, if no response and input from the rest, I assume that this training this morning doesn't stop here, and it start to let us to work on it, and then how can we see. By the way, DJ, from the SMC4, looking at the kind of 3D the AutoCAD they give to us, I look at it, okay, it look complicated. Now, what if we have this project, something like that, what should we ask, and where do we start to get the more appropriate information from the Aki? Maybe you want to show out that SMC4, how does it look and complication, and where should we start if this is what we have?
Like I said, the very first thing you should ask for is the AutoCAD plans. That will reduce your problems by half already. Once you have the plans, it's much easier to trace in Revit, or even if you're doing in IES, because the SketchUp file, I'm sure you cannot import it as a reference in IES. You still have to convert it into a DXF.
Mm-hmm.
And no way you can import the SketchUp as the energy model itself, because it just contains too much information.
Mm-hmm.
So definitely, if they only give you the SketchUp file, you'll have to export floor plans from it, and you have to create those floor plans individually for all those levels. So it's not gonna be a productive process for you. So ask for the floor plans first. Once you have the floor plans, you can see how easily we can assign a link in the CAD plan. And since it's 2D, it's light enough. And additionally, you can, for example, you have many floor plans for story, second story, roof, sky terrace. You can unload them as needed. For example, you've done the first story. You can just unload them to make it lighter on the program, and just have the current floor plan that you need loaded. So you're only working on that particular level, and it's going to be very light. This method of modeling is very light because we're not creating so many geometries. It's only walls, floors, and roofs. And our windows are very simplified. So that's why I prefer this doing it in Revit, because we usually work on very large projects like what you have shown for SMC4. And there's no way that I can use that particular SketchUp file. I can use it.
Sure.
I open it in SketchUp, measure the window heights from there, but the CAD plan is still the one that dictates the modeling. Okay, so it's just an added reference that you have that SketchUp file. Where's that? Because looking at it, it's it's 400 MB. It's crazy.
Yeah, big. Yeah. So in this case, of course, the SketchUp is just for us to see what kind of idea the building like. Of course, with the 2D floor plan, then we from there can build up the models and then come up something close to it, which is, I think, that is what helpful for us, right?
Yes, measure the window heights and the sunshade.
Good. Yep.
Okay.
Yep. Okay. The rest, well, I think DJ done a very good job for give us this training. I'm sure that we have some better idea and how to build a model and where to start from here. I hope that our team will able to come up with something and take this practice time to work on some project, and we can move on from here, because we're going to try. If this is very useful, the IES useful and save us a lot of time, productive, then we want to really go into it and using IES. If you find that end of the day, it's not much different for what we are doing manually currently, then we have an option to go. Okay?
Okay.
Good. Thanks everybody. Thanks DJ very much. Thank you.
Okay.
Thank you. Yeah. Good.
Thanks,
the rest,
guys.
if you have any more question, anything, feel free to just drop a DJ a line and he can guide you on that. Okay?
Okay,
Good.
I'll send the recording as well, so that if you want to go back through any of the steps, you can just simply watch the video.
Yeah, good. Thanks. Thank you.
Okay. Thanks, guys. Yeah, thanks.
Thank you. Bye.